Below are the following steps. The first step is to install the app endpoint manager used for application actually, RCMS and E2C. The E2C including southbound app, E2C broker, and northbound. For the convenience, E2C broker has been installed in the system by default. In addition to install the E2C app, please install the RCMS app. Because in step 5, you need to associate a device that has been certified in RCMS. Since the backup power uses Modbus for communication, the second step configures the Modbus parameters. Mainly import the battery, register address list, and set serial port parameters. These two steps are for the gateway. Then the configuration of the manager. Create a product, 8 parameters to be read, associate the gateway, and 8 visualization plugins, visualization indicator. Log in the gateway. The device is online. Please confirm that the necessary apps are installed. E2C broker is installed in the system by default. Configure Modbus parameters. Enable the app. These parameters about the time of Modbus. You can find the explanation on my LinkedIn post. Configure tag in GUI means that when the register address is relatively less, it can be configured directly on the web page. You can configure Modbus parameters on the web page. Only when there are less Modbus registered to be 8. However, when there are many registers address need to be read by the gateway, it is more convenient to use an Excel table. The gateway imports JSON file. You can edit the register address and the parameters on the Excel table, and then convert the Excel table into JSON file through E2C converter. I've downloaded the Excel template and E2C converter already installed. This tool can be downloaded from RCMS support webpage. Open the Excel table to edit the Modbus registers of the battery. I've edited in these batteries Modbus registers in advance. Here's the tag name and the protocol, the battery run in Modbus RTU, and the slave ID, function code, register address, data format, and can also set simple calculations. These addresses are obtained from the battery manufacturer. This is the battery instruction manual, which provides the battery queryable status register address table. Here are the registers list that can be read, and you can get the corresponding address and configure it on Excel table as needed. Then convert Excel to JSON file with the E2C converter. Select the corresponding protocol, hit the Excel file. Select the output path, convert. The JSON file is generated. Go to the Modbus configuration of the gateway. Import the JSON file. After submitting, you can see that the point table has been imported. Necessary to configure the serial port parameters according to the battery so that the serial port of the gateway and the battery can communicate properly. These time settings can be configured according to your needs. I use the default here. The gateway communicate with the battery use RS485, so here select COM2. If it is RS232, please select COM1. What is the baud rate should be set here? Here we should set the baud rate of the battery. Then let's check the battery manual. As you can see, this is the baud rate parameters, serial port parameters of the battery. Then configure it on the gateway accordingly. Submit and save the setting. At this time, the gateway starts to read the status data of the battery. Data read successfully. All data has been read via Modbus. The USI update enable. What is this button used for? This feature means that when I disable it, the read data will not be displayed in the status page. When there needs to read more than hundreds registers, it is recommended to turn off USI update because the web server needs to update the large amount of the data in real time, which will consume a lot of CPU memory. Usually, the data is viewed from the monitoring center instead of the gateway status page. So you can turn off the USI update. Then enable E2C broker. I want to clarify that the E2C broker here is not the MQTT broker. The MQTT broker is a server which is generally located in the monitoring center. This E2C broker is a message queue application. Its role is to decouple southbound and northbound. In other words, with E2C broker, the data collected by E2C Modbus can not only be reported to RCMS, but also to some other cloud like AWS, Azure. Southbound is Modbus, northbound can be any. Conversely, the northbound is fixed to a certain platform, certain cloud, and the southbound can be any. It can be Modbus, some other southbound protocol. When the network is abnormal and disconnected, E2C broker supports to cache the Modbus data to flash, SD card, or USB storage. When the network is restored, the data can be uploaded in linear or circular mode. Configure the server address on the on the northbound app. Check if the RCMS was connected. And next is the platform operation. Go to Endpoint Manager. Create product. Input product name. This is the Power Backup. Name it Power Core. You can upload a logo. Next. 8 data parameters here. The positioning parameters is already available by default. Just set the interval as needed. The reporting method supports scheduled upload or interval upload. Here we set the position to report it every minute. Since the battery doesn't do positioning, we use the get waits positioning data. What we want to read is the status of the battery, so we need to add the battery data field. Name it Modbus because the protocol used by the battery is Modbus. The battery status is also set to reporting every minute. Select the E2C app. Then go back to the Modbus point table. And select several data for demonstration. For example, I want to upload the remaining capacity to the platform. Input the name. The parameter name can be customized. And here you need to configure the parameter code The parameter code requires a fixed format. This is the parameter code format. This is the tag name. This is the model bus, the battery model bus address, and the data collected by the model bus and sent to RCMS. Please make sure that the tag name in the parameter code must be same as the point table, the tag name of the point table. Here I want to add the remaining capacity, and here is the completed code. Copy the code and paste it on the endpoint manager. Also, I want to read the temperature, the environment temperature, and use the same way to configure the parameter code. Just replace the tag name. And I also want to read the design capacity of the battery. The last is to configure the data type. You can find the data format, data type of the registers on the point table. This information also from the battery manual. Save the settings. These are the 3 status that we want to read. Enable the product. Here you can browse the edit data fields. Data fields cannot be modified after they are added. Then add end device. Add the battery. The brand of this battery is Sacred Sun. It belongs to PowerCore. And this battery is connected to this gateway. After adding, the gateway starts to upload the corresponding data to the platform. You can also check status of in the gateway. The node point is connected. That means it's uploading the data. Okay, the end device is online. So step 5 is completed. The last step is to add the indicator and plug into the visualization. Go to product management. and you can add the indicator here. You can associate the icon with the value. The data of this icon is not real data, it's just for a reference. Not only that, but you can also visualize data statistics with graphs, such as line graphs, to see changes in temperature. Or the capacity, the remaining capacity. Back to the end device management. You can see the real-time data here. The battery design capacity is 100 ampere. The current environment temperature is 23.9 centigrade, and the remaining capacity of the battery is 48.14 ampere. Here you can set the data reporting interval. You can change the setting here. The visual data analysis to intuitively know the battery status. Query historical data here. That's all for this demo. Thanks for watching. Bye.